Hey guys, so in this video we are going to be talking about GridView, ListTile, ListView, Stack, and Card. So over here we have a very simple Flutter application created using Flutter Create, and the first thing we're going to talk about is GridView. GridView.count. This takes in a parameter called cross-axis count. So you specify how many columns your grid should take, and then so in this case we're saying that the grid cross-axis count should be 4, should not extend, should not have more than 4 blocks per row. So it also takes in a children's array, and I'm going to paste in one child for now. Save it, press R, and you should have the same layout that has been displayed here before. Here we go. So just to illustrate what exactly cross-axis count 4 means, I'm going to just copy paste this a bunch of times, save it, and then press R in the command, and you can see that okay, you can't see this. So in order to make this thing more, you can see the blocks. I've added some spacing along the cross-axis and the main axis and the cross-axis. So now you can see that 4 means this is going to take 1, 2, 3, 4, and even if we extend this window out, it will still take 4. So it will essentially ignore the parameters in here of width and height, and just take each child and stretch it out to fit to divide the available space by 4. I'm going to take a moment to change the colors here just for some added pizzazz, I think. So I've changed the colors to just give it more, to make it more interesting, more visually appealing. So the GridView.count allows you to specify the cross-axis count you want. Then there's another type of GridView we can use .extend instead. So .extend doesn't take this cross-axis. If you hover over it, it will tell you, it will give you all the information you need or it requires. So the name parameter marks as this is what is required. So what maximum cross-axis extent does is it tells the GridView that each child should only take a maximum of 100 device independent pixels width and height. So that if you take this and you stretch it out, what would happen is, because you're telling each child takes only 100 device independent pixels width and height, that as it increases and there's more space left, it will just take the grid items or the containers that are down here and push them onto the top line. So if we made this like very big, let's say 500, and then press R in the terminal, you can see what happens now is that it makes sure each one takes 500. That's the maximum it's allowed. So it takes the maximum width allowed. This is about 1500 pixels widthwise. So it takes 500, and then pushes the rest down. And if you make it really small, because this is very large and most devices are not wider than 500, this would mean that only one container, or only one child would take up the grid space at a time. So that there is something else on GridView before we close up on them called scroll direction. So as of the moment, the scroll directions default setting is set to vertical. So if we save this, there's really no difference. It just scrolls vertically. The other thing about GridView is an important one. I almost forgot. It allows scrolling functionality. So whatever is held in the GridView can be scrollable. So quickly switching over back to GridView.count, there's one more important thing about grid, other than the fact that it allows you to scroll through the children. There's something called cross direction, and normally its default is cross direction.vertical. If we save this and we press R, the grid view will just behave in the same way. If you made it horizontal, your grid view is now scrollable horizontally, and that's very cool, and it explains some of the interesting layouts we see on mobile devices. The next thing I'd like to take a look at is the ListTile component, a layout component. A ListTile component is a component. It takes a title, a subtitle, and optional icons at the beginning and the end of the ListTile. So if we save this, the screen will be blank as expected. So let's start giving our ListTile some parameters so we can see something here. So we've given our ListTile a title and a subtitle, and if we save it and press R, we should see. So the ListTile comes with this styling where the titles it's given more of a higher visual hierarchy by making it bolder than its subtitle. And then we can also give the ListTile trailing and a leading icon if we want. As I can't think of a situation which should use both, but just for the purposes of learning. So we've added a trailing widget to display after the title, typically, and we can also put images and anything else really as a trailing and a leading icon. So when we save this, this is what a ListTile looks like. It takes in an icon or an image at the beginning, same as at the end, and it organizes its stuff like this. So a ListTile is not very configurable. You can't really do too much with it. It's like a built-in widget that you can just feed in data and it works, and it's already set out beautifully for you. So the ListTile component has a couple of other parameters it takes, but the most important one usually is just the title, the subtitle, and either the trailing and or the leading icons or images, depending on your layout needs or your UI needs. So the next one we are going to take a look at is called the ListView component. So ListView component is somewhat similar to our GridView component in that it allows you the ability to scroll through. So it will scroll through its children. Usually ListView is used with ListTile. So we can give it, say, a ListTile. Let's save that and see what shows up. So I've given it one ListTile. I prefer trailing commas. So I've given it an icon for the trailing comma, and now we can copy paste this down a bunch of times to show that the ListView allows scrolling. So when you save that and press R, you can see that our ListTiles are longer than the viewport height. So ListView allows it to just scroll through. So there's no overflow error that comes up, or that yellow black boundary that Flutter usually throws up when your view is larger than the screen size. Another important thing about ListView is that you don't necessarily need to give it ListTile, so it is the most commonly used case. You can give it any type of widget as part of its children, and it will just make it scrollable. Its main work is to make its children scrollable. The default scroll direction is really vertical. So as an example, we can just give this an image. So in this case, I've given the ListView a ListTile, an image, and just a plain text. And we're going to see that it's still going to be able to scroll this down. So I'm going to copy paste it down a couple of times. I think that's enough. Save it, run R in the terminal. And as you can see, it still makes it entirely scrollable. The image, the text, the ListTile, the image, and the text. That's all for ListView. So the next layout widget we have to talk about is stack. So the stack takes in an array of children and uses the first child in this array, the first element in this array, as a base widget, which means that every other child that comes in that array will be placed on top of the base one, in this case image.network. So I've just given it image as a base and text, and then I've given the text size, I've made it a bit larger. So when we save this and run R and then auto reload in the terminal, this is what we see. Screen, the text on top of the image. And if we do, we can manipulate the alignment of the widgets that are not the base widget. So in this case, it's only text that's being put on top of image, so this alignment would apply to text. So alignment.center, as you can see, when you auto reload, it moves the text to the center of the image. If you press, you can see everything that you can, every way in which you can align the text. If we say top center, for example, we expect to see it over here, at the top center. So it would seem therefore that its default positioning is top left corner. If you were to remove this completely, save and reload, that's the defaults. So essentially, you can move around, you can play with the alignment of this, of the text in this scenario using the alignment argument that you pass to the stack. You can also align more stuff on this one. Let's make this 2 texts, and the stack just aligns the first child as the base and any other child on top of it. Essentially, the way the data structure stack works, where you whatever you put on top comes on top. It's literally, it's last in, first out type of scenario. So like the first thing you put will be at the bottom of the stack, then anything you add will go on top instead of at the bottom, as you would normally expect in queues where it follows, the first in, first out scenario. This is last in, first out. Essentially, that is how a stack works. And we are left with one more layout widget for today's video, called a card. I have a card over here that I'm just going to take us through to avoid the video getting way too long. If we run R to just see what we have over here. So this is the card that we made. As you can see from just this layout, that we have an image and 2 list tiles and a divider over here. So now let's go back to the code and study it to understand a bit better what's going on here. So for the build context, we've given it a column and it takes an array of children. We've given it an image. We've specified the width of the image, a list tile, which we've already talked about. We use content padding to give margin. There is no CSS margin in that directly, so we use agent sets to get the same result essentially. So agent sets at all, and then text type, we've given it a title. We've styled using text style, we've given it an accent color, subtitle, a trailing. It's just what we've been discussing on list tile. A divider is a component that results in this faintly visible line here that creates just a visual separation in your layout. And then another list tile, and then the new widget that we are seeing here is size box, which is just a widget that creates space, essentially creates a fixed size box. So it just creates space. If I make this, in this scenario, it creates this bottom space below the second list tile. You can see this is a list. Without it, you see that there is no that space at the bottom of this. It's just the 20 edge insets that I've applied to it, giving it padding of 2020 all around, and then I've used this to give it extra space. There's more ways you can achieve this. I just really like the sized box widget. I'm getting used to saying widgets instead of components. So that's really just it. But the card it's a material card component. It's already sort of pre-made for you. You just give it certain arguments. Okay, so about the card, the card takes in children. You can give it a list tile, you can give it images. That's why I've mixed up the type of widgets I'm feeding it. There's an image, there's a list tile, size box. Essentially, that's really all with the card. You can give it a margin. The card itself, in this case, the card itself has a margin around it. There is this one here, main axis size.min. It minimizes the amount of free space along the main axis. So it sorts of packs the children together nicely so that they don't just look so far apart. Main axis.min just packs together the children more closer together. Let them take the minimum space they need instead of spreading out. So that's mostly it with the card. It's a material card. It takes in one child, so you need to give it a child that can take an array of children, and then it arranges them in this manner. You can control the elevation of the card, which is what I've done here. I've given it more box shadow around it. So in the next video, we're going to take all of this knowledge you've gathered on the different layout widgets and combine them together to make really interesting videos. I'm looking forward to that. I hope to see you there. Thank you so much for the support. Please like the video if it's given you value. It allows it to spread to other people like you and I who are trying to learn Flutter. And see you in the next one.